The last section for this unit is modeling functions, and our essential question is how do we determine how two variables relate to one another? Example 1 is a little bit outdated, but cell phone plans used to charge per text message. So we have Plan A that charges $20 a month plus 5 cents per text, and Plan B only has a monthly fee of $5, but we're charged 10 cents per text. Part A is to write a function for how much Plan A would cost depending on how many texts we send. I'm going to name this function A because it was for Plan A. I'm going to call the variable T because it depends on how many texts we send. We are charged $20 no matter what every month, plus an additional 5 cents times the number of texts that we send. For part B, I'm going to name this function B. Again, texts is the variable. This time we have a $5 flat fee plus 10 cents times the number of texts we send. Part C, we are asked to determine how many texts we would send to make both plans equal. So what we will do is set the equation for part A equal to the equation for Plan B. And then we'll solve for T. When I have an equation with a variable on both sides of the equal sign, I like to get my variables together first. I subtract the variable that has the smaller coefficient, so I'm going to subtract 5 cents from both sides, subtracting 5 from both sides, dividing both sides by 0.05, we get 300 texts would be the amount to send in order for Plan A and Plan B to cost the same. This answers the first question. The second question is, what would the cost be? We can substitute 300 into either function because they will both be the same at 300 texts. I'm going to choose Plan A, so we're subbing 300 in for the number of text messages that we send. $20 plus the $15 for the text messages would give us a total of $35 for our phone bill for the month. Example 2, we're looking at a toll road, or you can buy a monthly pass to get a discount on the toll. So part A is for the charges without the discount pass. I'll call this function T for the toll road. M for miles, because that's the variable in this case. It depends on how long we're on the toll road, how much we pay. Without the pass, it's 25 cents per mile. Part B is the function for the discount pass. I'll name this D of M. For discount, we would pay $15 for the pass, plus we would only pay 10 cents per mile this time. Part C, very similar to example 1. How many miles would we have to drive in order for the charge to be the same with or without the discount pass? So we will set the function for the toll roads equal to the function with the discount pass and solve for M, subtracting that 10 cents from both sides and dividing by the 0.15 or 15 cents. In this case, it would be 66 2/3 miles. Our second question is, what would we pay to use the toll road for the 66 2/3 miles? Our first function is a little bit simpler, so I'm going to substitute my 66 2/3 miles into that one, multiplying that 66 2/3 by the 25 cents per mile would give us a total of $16.67 to use the toll road, whether or not we have the discount pass if we drive those 66 2/3 miles. Final example, we have a machine that's creating open boxes. Normally when we see a box, we have a cover on top. In this case, these boxes will just have 4 sides and a bottom. The sheets that they are formed out of are 10-inch square sheets of metal. In order to form the open box, it would cut squares out of each corner, of course congruent squares, and then fold the sides up to form the 4 sides of the box. We're going to write a formula for the volume of the box depending on the length of the side of each of those squares. I'm going to call the length of each side x. So what we need to do is figure out what this length would be. That would be one side for the base of the box. This would be the other side for the base of the box. And then thinking about folding that up, this value here would be folded up. That would give us the height of the box. That we know is x because it's the length of the side of that little square that's cut out of the corner. So what we need to figure out is what this value is. If the entire side is 10 units, and we are cutting away a square that is x units here, and another square that is x units here, we're taking two x's away from that 10 inches. If you think about the other side, I'm going to work down here because the top is getting a little bit clustered. It's the same value. We've got 10 for the entire side length, but we're taking away two x's to leave us with the other side of the base. So the volume would be 10 minus 2x squared for the square base times x for the height of that box once we flip those sides up. Part B, we need to know what the domain of the function is. Now looking at the function itself, we can multiply all numbers by 2, we can subtract them from 10, we can square them, and then we can multiply them by x again. However, when you look at that picture, the square that we cut out can only get so big before you cut the entire sheet out and there's nothing left to form a box. So we have to think about the fact that 10 minus 2x needs to be greater than 0. If it's not greater than 0, there's no sheet left. Adding 2x to both sides and dividing by 2, we get that x needs to be less than 5. And finally, you have a U-Try question.